Up to this point, you have written several programs, several interesting programs, where you have even made decisions on whether to execute or not some statements based on conditions, conditional execution of statements. In the problems we have seen so far, we deal with a fixed set of input data or a small number of values. What is missing? This time we are going to add more data, and in order to deal with more data, we will need to perform repetitive actions. There are two ways to think about repetition. One is that we perform the same operation on different data. The other is to accumulate information over a set of data. For example, assume that you read lines of text from a file and then you check for each line something. For instance, you check whether or not it is a palindrome. This is an example of performing the same operation on different data, every single line of the file. If we read numbers from a file and then compute their sum, for example, this is an example of an action where we accumulate information, the sum, over a set of data. When we write code that involves repetition, we pay attention to two parts. One is the body of the repetition, the group of statements that are going to be repeatedly executed. The other is that condition, the statement that controls when that execution is going to stop. How many times are we going to repeatedly execute that body of code? So the golden question becomes, how do we make sure that every time we execute the same piece of code, the same lines of code, something different, something useful happens? Imagine, for example, that we are reading lines from a file of text, and we want to read all of the lines of the file. What will mean that we need to make sure that the state of the computation changes? We need to make sure in the body of that repetition that every time we read a different line of the file, that the cursor has moved to the next line of the file. When we reach the end, that will signal that we no longer need to repeat the body. We have read all of the lines. Or for instance, suppose that we write a program that we walk. We take steps until we reach, say, a door. At every iteration, at every time we take a step, we need to make sure that our position has changed until we reach the same position as the one that the door is, at which time the Boolean expression that will determine whether or not we need to keep the repetition happening will become false, and we will no longer repeat a particular set of statements, the body of the repetition. So the key thing to make sure is that the state of the computation changes with each iteration, every time we repeat the same block of statements. There are two kinds of iteration. One is named indefinite. We loop, we repeat the execution of the statements until our job is done. We don't really know how many times we are going to repeat the execution, how many times we are going to loop. We only know some kind of condition that will be satisfied when we have reached the end. The second kind of iteration is the definite kind. Repeat a given number of times. Loop until a particular variable, a particular counter has reached a particular value. In Java we have three repetition constructs, three different syntaxes through which we can write repetition statements. One is called the while loop. The second one is very similar and is called the do-while loop. And finally, the third one is the for loop. We're going to examine each of them and find out their specific characteristics. We write a while loop by starting first with the while keyword. After that, inside the parentheses, we write the condition, the Boolean expression determining when we're going to stop executing the loop. In other words, as long as the condition that we have inside the parentheses is true, the statements that are in the body of the while loop, the statements within the curly braces, are going to be executed repeatedly. In a step-by-step form, what is happening? The execution starts by testing the Boolean expression first. If it is true, then the statements that are in the while loop are executed. And finally, we repeat from step 1. So again, we test the Boolean expression. If it is true, we execute the same statements again. The do-while loop is very similar to the while loop, as you probably infer from the name, but it has a key difference that you need to keep in mind. Take a look at the syntax. You will see that the statements, the body of the while loop, is first, and after that is the condition that determines whether or not the loop is going to be executed once more. What does that imply? It implies that the body is going to be executed at least once, even if the condition that is in the parentheses never was and never will become true. The body of the do-while loop is going to be executed at least once. If the condition is true, then it is going to be executed once again and once again for as long as the condition remains true. Once it becomes false, then the control of the program is going to continue with the next statement after the loop. The previous two repetitive constructs, the while and the do-while, are examples of indefinite iteration syntax. The for loop is a definite iteration construct. And let's pay close attention to every part of a for loop so that we understand very well how it works. As expected, a for loop starts with a for keyword. After that, we have a parenthesis, and this time in the parenthesis we not only have the condition that determines whether or not the loop is going to be executed once again or not. We have two more statements. First, we have the init statement. This is a statement that is executed once and only once at the very beginning before anything else happens. The init statement is not executed repeatedly, even if the body of the loop continues to execute for many more times. The init executes only once. After the init statement, we write the condition statement. This is the condition that will determine whether or not the loop will keep on executing. The third expression inside the parentheses is the increment part. The increment part is always executed at the end of the loop statement. Unlike the init statement, the increment part is executed at every iteration of the loop, and it is executed always at the very end of the loop statements. As expected within the curly braces, we have the body of the loop, which are the statements that are going to be repeatedly executed as long as the condition remains true. So let's take a look at the step-by-step guide on how the loop executes. First, evaluate the expression init. Remember, this happens only once. Second, evaluate the condition. If the condition is true, then get inside the body and execute the statements of the for loop. Third, evaluate the increment expression. Execute the increment expression. Finally, return to the second step. Again, not to the first, but to the second, which means we're going to evaluate again the condition. If it is true, we're going to execute the statements of the body and then the increment statement. Then again, evaluate the condition. If it is false, then we exit the loop and we continue with the next statement after the loop in the program.